Hello, welcome to this video with the 2.2 practice set. I will be going over the solutions to a few of the problems, not necessarily even or odd, but just a couple. And then the ones that I did not go over, of course, you are responsible for completing and turning in. So let's look at number 1. It says given, or let's look at the instructions first. It says support each conclusion with a valid reason. So they will give us some information, then they will draw a conclusion, and then we have to say what property, what reason justifies them being able to draw that conclusion. Okay, so you'll be using that long list of properties from the 2.2 guided notes. So let's take a look at number 1 now. It says given if 15 equals C and C equals Z, the conclusion is drawn that 15 must equal Z. Okay, so let's look at this. We have 15 equals C and C equals Z. What did we repeat? We repeated the letter C in here twice. So we have C being equal to two different things. C is equal to 15. C is also equal to Z. That means those two things are also equal to each other. Basically, you can get rid of the variable that's repeating or the item that's being repeated. You can get rid of it, and what's left over have to be equal. That property, the justification for that is the transitive property. Remember that from the notes 2.2 guided notes. Transitive property addresses this occurrence, okay? Number 3, this time we are given an equation 6x minus 2x equals 52. We draw the conclusion that 4x must equal 52. So let's think about this. We want to compare the given equation to the conclusion equation. How are they alike? How are they different? Well, we can see on the right side of the equation, it stays 52. That does not change, okay? So if one side of the equation stays the same and does not change, then we know it's not going to be addition property, subtraction, multiplication, or division, because those 4 properties require you to make changes on both sides of the equal sign. But 52 stayed the same, okay? So what changed? Well, 6x minus 2x became 4x. So basically, they just subtracted those common terms. 6x, 2x. You subtract, you get 4x. So all they did was combine like terms on one side of the equation. And so that justification or that property is going to be combined like terms. Make sure that you don't put subtraction property here. You might think that's the right answer. It's not subtraction property because we did not subtract on both sides, okay? And then you might also think simplification, not simplification here because we can be more specific about what we simplify. We simplify like terms. So we want to make sure we put that as the property, okay? So that's 1 and 3. You'll be responsible for 2 and 4. If you have questions, ask during the class or comment in this section of the course or in the comments for the video, okay? So now that we've practiced using properties to justify reasons for drawing conclusions, let's use this skill to do some 2-column proofs. So we have 3 proofs here, 2, 3. Let's definitely do this one together, number 3. And you guys will be responsible for 1 and 2. Let's look at number 3. Remember from the notes that every time you do a proof, the given information goes down as the first statement every time. So this equation is given to us. That will have to be the first statement here. Just copy it just like it is, minus 3, 4x. Okay. And also remember that the very first reason is always given. So that should be the first line of your 2-column proof every single time. Does it always work this way? Yes, it always works this way, okay? So now that you have step 1 done, what we would like to do is go through each one of these statements and provide the reason or the justification for why we were able to make those steps. Okay, so I'm going to go through my complete thinking process as we go through this example, right? To come up with reason 2, I have to determine what happened between statement 1 and statement 2. What occurred? What's the difference between statement 1 and statement 2 that will help me come up with the reason for statement 2? Okay. So I like to compare. I said, well, how are they alike? -3, -3. I still see parentheses. I see 4x. I see -2. I still see the 1. All of that's the same. What's different? Okay. Notice in statement 1, there was a 10. The 10's not there anymore for statement 2. Also notice in statement 1, it was equal to 77. But 77 has now become 67 in step 2. So I asked myself, how do I go from having a 10 and it disappearing and 77 becoming 67? What did we do? Well, we subtracted. We subtracted 10 on both sides. 10 minus 10 would go away. On the left side, there's no 10 anymore. And 77 minus 10 would be 67. So this would be subtraction property because we subtracted 10 on both sides. As long as you subtract the same item on both sides of the equation, we can use the subtraction property. Okay, let's move on. How do we go from 2 to 3? How are the statements alike and different? Well, -3 is still there, the parentheses is still there. The 1 is gone, and 67 becomes 66. 1 is gone, and 67 becomes 66. So once again, we do the same thing. We subtracted 1 on both sides. So once again, we have subtraction property. Not bad, not bad. Okay, remember, just go step by step. So continue on. What do we do from step 3 to get to step 4? How are they alike and different? Let's compare. 66 and 66 stayed the same. The right side of the equation was not touched. Okay? But let's look over here on the left. The 3 is gone. The 4 is gone. The 2 is gone. The parentheses are gone. Okay? So anytime I have parentheses, that kind of makes my radar go off and think, oh, that's probably going to be distributive properties. Not always the case, but parentheses do give me a signal that distributive property is at least possible. Okay. Anytime I have parentheses and they go away, which is what happened from 3 to 4. But then you also have to check to make sure that there was multiplication. So -3 times 4x is -12x. Let's see that. Let's make that stick out. -3 times 4x is -12x. And then -3 times -2 is +6. So notice how this 3 was multiplied by everything in the parentheses, and then the parentheses went away. That is exactly what distributive property is. So we need to put the statement or the reason for number 4, distributive property. Okay. we were able to distribute -3 through. That's how we created statement 4. And therefore, that is reason 4 right here. Okay, we're almost done, guys. Hang in there. Next, we want to compare 4 to 5. What happened? Okay, well, let's see. 12x and 12x stayed the same. No change there. But this 6 is gone, and 66 becomes 60. Okay, so 66 decreased to 60, and 6 went away. All right, so we've seen several examples of that. That's going to be subtraction property. We subtracted 6 on both sides. All right, one more step. This time we need to create the statement. Remember, we're trying to prove that x equals -5. That should be the last line of your proof. Whatever it says prove, if you do your proof correctly, it should always be the last line of the 2-column proof. And this should make sense, because if you solve this equation using algebra, which you have taken the course algebra already, divide both sides by -12, and x will equal -5. And since we divided both sides by the same number, then the property or the reason is division property. Okay, and that is a 2-column proof. Now, we were lucky this time because they gave us the majority of the statements. When you move into the next lesson, 2.3, they will not give you the statements. You will have to come up with the entire proof from start to finish, okay? So this is the skill we're working on in this lesson, to be prepared to do it all on our own in the next one. Okay, so now that you've seen proof number 3, you should be able to go back and do 1 and 2. Take your time, justify every single step. All right, moving on. So the front was algebraic proofs. Let's put some more geometry in it. The instructions here say draw a picture to represent each given situation and justify with a reason why each conclusion can be made. Okay, so that's for 4, 5, and 6. Let's look at number 4. Given point D is on segment CE. You need to draw this picture. That's what will help you. Draw segment CE. Perhaps we need a color here so we can see it. All right, so that's my segment. And I need to put the points CE on it. Point C, point E. So that's segment CE. And then we need point D on the segment, anywhere. They didn't say where to put it. Just put the point on there where you prefer it to be. So I'm going to put it here. Okay, so that's the picture. The conclusion is made that CD, this short segment, plus DE, this segment, is equal to the entire thing CE. That is the conclusion that is drawn. So they are saying red segment plus blue segment equals the entire burgundy segment. And we know that that is true, but they're not asking about true or false. They're asking, how do you know? What's the reason? And if you remember back in chapter 1, we talked about segments being added in the same way. First segment, second segment equals the whole thing. That justification is segment addition postulate. And think about it, we're adding segments. So that would be the name, segment addition. Okay. And so you want to do that same thing for number 5 and number 6. Draw the picture and then go back and pull the topic that we learned in chapter 1, and that's going to be the reason. Okay, so number 5 talks about angles and bisectors. Okay, and then 6 talks about midpoint. So think about those two vocabulary terms, bisector and midpoint, and use that for your justification. Last one I will include is an explanation. Let's take a look at this proof. They do give us all of the statements, which is really nice. They give us all the statements. So let's work this out. We're given the measure of angle 1 is equal to the measure of angle 3. Just making that stick out in my picture here. Measure of angle 1 equals measure of angle 3. That is given. That's always your first reason every single time. Next, it says the measure of angle 2 equals the measure of angle 2. Well, we know that. It should be obvious that everything equals itself, but we can't just put duh as the reason. You have to have a property or something to put right here. And in this case, if you remember from the notes, there's a property specifically for this. When something equals itself, it is called a reflexive property, kind of like your reflection in the mirror. All right, good, moving on. Now we have measure of angle 1 plus measure of angle 2 equals measure of angle 3 plus measure of angle 2. Look at the similarities between 1 and 3. Statement 1 and statement 3. Look at those. Okay. 1 is still on the left. 3 is still on the right. See that? Okay. But what did they do? Looks like they added angle 2 to both sides. So they added the same thing to both sides of the equation. And anytime you do that, that is the addition property. Okay, hang in there, hang in there. We only have 3 more steps to go. You're doing good. Okay. So let's look at statement 4. It says measure of angle 1 plus measure of angle 2 equals LPN. That's a good sign for me to go back to the figure. Let me highlight some things and see if this makes sense. Angle 1 is right here, it's labeled. Angle 1 is this slice of the pie. And then angle 2 is labeled as well. It's the very next piece. Okay, so you see red and blue right beside each other, that's 1 and 2. It says those two add to equal LPN. What's LPN? L, come down to P, then back to N. Look at that. Orange is both the red and blue combined. That's all together. Okay. I think we talked about this in chapter 1, right? When you have 2 angles, 2 slices of pie, side by side, adding to be the bigger piece of pie. We're adding angles. You got it. This is going to be angle addition postulate. Chapter 1 information. Remember, you can't forget anything. It's all going to build on itself. Okay, so that was that. Let's look at statement 5 and see if it tells us anything else. It says measure of angle 3 plus measure of angle 2 equals OPM. In this case, we would use the figure again. Look, 3, 2, OPM. Let me highlight it to make it stick out too. I'll delete these other ones that we had before, just so we can make statement 5 a little bit more obvious. Okay, so let's say that measure of angle 3 is red. And angle 2 is blue, just like it was before. So we have the blue slice, the red slice right there together. And then OPM. OPM, once again, is the entire portion there, red plus blue. Red plus blue does equal orange. That's true. Again, and again, we want to put angle addition postulate. We're adding angles again correctly. So one more thing and we're done. So they conclude that LPN is equal to OPM. LPN is equal to OPM. How can they draw that conclusion? Let's see. Let's look back in the proof. Remember, I'm going to delete some things and make it clear too. Let's delete this circle. Okay, so remember the measure of angle 1 plus the measure of angle 2 right here was equal to the measure of angle 3 plus angle 2, right? Remember that? Look, angle 1 and angle 2, they tell us is LPN right here. Dark blue equal. Then they tell us in statement 5 that 3 and 2 is equal to OPM. Okay, so dark blue is equal, light blue is equal. That means you can substitute them as you choose to. You can take out and replace with each other interchangeably because they're equal. Okay, so that's exactly what they did in statement 6. Instead of writing M1 plus M2, they substituted and just use LPN, dark blue. And instead of writing M3 plus M2, they substituted OPM, the light blue one. And what property tells me we can substitute when we get ready? If things are equal, that's the substitution property. And that is going to conclude this proof. Okay. So this is the 2.2 practice set. Please use these explanations of the problems that I did do to help you as you work on the ones that I left blank for you to complete. And then also this is a good preparation moving into lesson 2.3. Okay. All right, take care, guys.